Okay, for today, it's day 2 of right triangle trig. We still have right triangles, although sometimes we don't have a right triangle. What if it's a big obtuse triangle like that? Do you get you can still make it into a right triangle problem? You just drop, it's called dropping a hypotenuse, or dropping a height. Anyway, and then I can say that's a right angle. And if I know this is 30 and I make that a right angle, do you get out of it? This has to be 60 right there. See what I'm saying? So if it doesn't have a right triangle, we still need to make it have a right triangle. You haven't gotten to the place yet where you'll be able to find the sine of 120 degrees. There is a way to do it. And it's not just looking at sides of a triangle, though. It gets more complicated. I'll teach you that later. But for right now, if you don't have right triangles, you make them. But let's say, here's the simplest of them all. We've got a right triangle, and it's got an angle, and let's say it's 30. And this side over here is like 5. There is 2 different ways to figure out this side. I'm going to call it x. There's 2 different ways to figure out x. You can either write a trig equation, or you can draw your helper triangle. I like to call it the helper triangle. It's the classic 30, 60, 90, and it doesn't have a side of 5 there. What are the dimensions on this classic right triangle? All right, so we have a 5 here, but on this triangle, it would be the classic one. It would be a 1. And what are the other numbers? 1 and then 2 and then square root of 3. Good. 1, 2, square root of 3. Do you get that you can say, oh, you've made it 5 times bigger, and therefore I can do that? That's a way to do it. But there's also a way to get this x by using trig, like cosine of this equals that. I didn't use the right function on purpose. So I want you to do it once with a trig equation and find out x with a trig equation. And I want you to do it once with the side ratios and say, oh, this ratio of 5 to x is a lot like this ratio of 1 to root 3. So do it once with trig, sine, cosine, or tangent, and do it once not using trig, but using the side ratios. All right, I know that one of those 2, usually kids know one of the 2 ways, but knowing both is harder. So please do it both ways. I'm going to pause for a minute while you work on that. So here we go. There's 2 ways. I personally like this way. Sine, cosine, or tangent. So, ka, toa. I know some of you are beyond this. You're like, oh, obviously, you're going to use tangent. But I don't have the hypotenuse. That needs a hypotenuse. That needs a hypotenuse. So I have to use tangent. That's a way to think it through. See what I'm saying? So I have to use tangent. Tangent of 30 is going to be opposite over adjacent, 5 over x. Raise your hand if you guys set that up. Okay, that's a good way. There's other ways, but then tangent of 30, I go over here and look at my helper triangle. Missing it's 1. Tangent of 30, toa, is 1 over root 3. So 1 over root 3 is 5 over x. And then, I don't know if you know this, but when you have an equal sign, you can cross multiply, and that makes it 1x equals 5 root 3. So x is 5 root 3. Raise your hand if you had that one right. Okay, cool. Option B is to think of this without any, notice I will never use the word tangent as I'm about to solve this. Okay, I can say 5 is 2x as 1 is 2 root 3. Do you get when I still cross multiply it? I still get x is 5 root 3. Notice I never even used tangent. Okay, so there's 2 ways to do it. And there's more. You could have done it a gajillion ways, but I wanted to make sure you knew a trig way and a not trig way. Okay, so next step is, what if you know only part of a side? What if I knew from here to here was 20, but from here to here, I don't know. So I'm going to call it x. And then this side is, let's say, 30. And let's say this side, or this angle right here, let's keep it simple. It's a 30-degree angle. And I'd like to know how big x is. Write an equation for me. Again, you could do it 2 ways, but this time I would recommend a trig equation. Sine, cosine, or tangent of something equals something. And I know you're thinking, do I use the 20 or do I use the x? You use both somehow. Okay, I know you may not be done with the solving, but at least did you catch on that this was, again, no hypotenuse. We don't know what this is, so I better not use anything with a hypotenuse in it. So tangent of 30 is equal to opposite, 30, over adjacent, which is 20 plus x, or x plus 20. Raise your hand if you figured that out. Okay, cool. All right. Next thing, of course, tangent of 30 I can figure out pretty quick. I just go over to my helper triangle, and tangent is opposite over adjacent, so it's 1 over root 3. 1 over root 3. That comes again from the 30, 60, 90, 1, 2 square root of 3 triangle. If you can't draw that out quick, you're hurting yourself. You got to get good at drawing that out, making it really quick, because you'll use it all the time. Okay, so back to, I would then cross multiply and solve. This isn't super tough from here. That times that makes just 20 plus x equals that times that, 30 root 3. And then to get the x alone, subtract 20 from both sides, and you get 30 root 3 minus 20. Okay, any questions on that one? Yes, sir. I don't expect you to simplify it any more than solving for x. So there we go. X is 30 root 3 minus 20. Now, if we had a calculator on the test and it said, give your answer to 2 decimal places or something, that's a hint that we want you to finish it. But this is super accurate. Think about it. That's actually more accurate than if we used a calculator, right? Calculator's going to round it. So that's super accurate. All right, now, what if we had two triangles, a triangle in a triangle? That's another classic honors pre-calc level. Actually, even regular pre-calc does these. They're not super tough. But if you have one triangle inside the other triangle, you got the potential for 2 30, 60, 90 triangles nested in each other. So let's say this is 30. And let's say this is, what do you think? Say that's 60. I could have said it was 45. You know what I'm saying? Whatever, it's bigger than 30. Then, do you get, I have the red triangle and I have the black triangle that's nested inside the red triangle? Then do you get, I might know this distance here. Let's say this distance on the bottom of the black triangle is 12 meters, but I don't know this distance. Now, you could now set up 2 equations. I'm going to make this a, that's 30 degrees, and this is 12 meters. If that's 12 meters, and that's a 60. You know what? You could figure this out. That's a 30, 60, 90 triangle. You could figure out how long that is pretty quick, couldn't you? You figure out how long that is. And once you've got how long that is, it won't be hard to figure out how big x is. So my just advice to you is, let's figure out this. We'll call it h for height. Figure out h first. Once you know h, you can use that to find x. Okay? I'll pause for a moment while you give that a shot. It involves 2 steps. Find h first. Okay, let's see how you did. I personally would have started with this, as I mentioned before, and solved for h. And I'd have been thinking, all right, sine, cosine, or tangent involves this and this. Tangent. Tangent of 60 equals h over 12. Didn't you guys start that way? Yes? Okay. So then, tangent of 60, it'd be kind of handy if I had my 30, 60. You're going to see me draw this a gajillion times. 1, 2 square root of 3. That's a funny looking 2, I know. I should probably fix it. It looks like square root of 2. Now I'm going to do tangent of 60 is opposite over adjacent. Root 3 over 1 equals h over 12. From there, I can pretty quickly cross multiply them, and h is 12 root 3. Raise your hand if you agreed with that. Okay, cool. Once you know that's 12 root 3, then it's not too tough to figure out this one, because I go, that's x plus 12, and I would do tangent of 30 degrees is equal to 12 root 3 over, tangent is opposite over adjacent, right? The adjacent side is x plus 12, and you can solve it from there. Tangent of 30 is 1 over root 3 equals 12 root 3 over x plus 12, and cross multiply, and you have x plus 12 equals, what's root 3 times root 3? It's root 9, which is 3, and 3 times 12 makes 36. And then I subtract 12 from both sides, and I get x equals 24. Did you guys get 24? Okay, cool. All right, so now the ultimate challenge. That time, you could quickly figure out this h, and it became easy to do once you found h. So now here's the new question. You're not going to see this at home on the video, but I have it set up where I have a stormtrooper, and he is aiming a sight line up to Wolverine sitting on top of my cabinet. And it looks kind of like this. Everybody draw this. You don't have to draw the detailed pictures with action figures, but anyway. You get how that basically makes a great big right triangle? And there's a guy down here. There's a guy up here. And we need to know that distance. Would you agree that that distance is the hypotenuse of our triangle? Let's call it h. Okay. Next, what again you can't see at home is that he's sitting on a table here that's only this long. So he can't just like there's a gap here where he can't walk over all the way over to the cabinet where Wolverine is sitting up here. But he walks all the way to this edge of the cabinet and does a resighting and figures out that that angle is 60 degrees. I'm going to draw it a little bit further because in the real world 60 degrees doesn't look like that. A little bit further like this. There we go. Then I can call this 60. And this is 30. See what I'm doing? Same basic thing as before, right? And he paces this distance off, and he knows this distance is 200 meters. The question is, just from what I've told you, I don't even need to tell you anything more, you can figure out how long that hypotenuse is. You're going to probably need to write two equations. One for the, I'll call it the black triangle here, and one for the original big triangle. I'm going to call it the blue triangle that goes here. Now, just so that everybody stays the same when we're comparing later, let's call this x and let's call this y for distances, because we have to pick a letter anyway, and if we all pick the same letters, it's so much easier to compare answers later. Okay, and I'm not going to put a W up there just to not confuse it with something else. All right, so the question is, how long is that h? That's the targeting line there. And I'll tell you, the answer is like 300 and something, but you're gonna use a calculator, but only at the very end, because you're gonna use sine of 30 or cosine of 30, but you can do those. Anything with 30, 60s, you can do those without a calculator. But at the very end, to get your final answer, you're gonna have to take the square root of like 150,000. You're not gonna be able to do that in your head. So use the calculator, but only at the very end. Okay? This one should take you a neighborhood of 10 minutes-ish, unless you're geniuses, in which case 5 minutes. Okay, go. Okay, I need to give you one more hint. You know, on the last problem, you just, go figure out y first, and then you can't do that when there's two variables like this. You're going to need to have one equation that's got an x and a y in it. I know you're not solving for anything, but you'll have an equation that has x and y, and another equation that's different that has an x and a y. And then when you have two equations with two variables, you can stick the one in the other. Okay? So I don't want you to think this is as simple as, I just found y and y is 30 and then I'm done. No, you'll need two equations that have x and y in it. Okay, go for it. Okay, time to wrap this up. Let's see how you did. If you haven't finished yet, then at least you can tell if you got it going in the right direction. All right. So first thought, I would have said, since I don't know the hypotenuse, I'm going to go back to tangent. And I really want this to only have two variables, y and x. If I throw in another variable, I'll have three variables, but two equations, and that's not enough to solve it. If you haven't learned this rule yet, you always want to have, if there's only one variable, you can have just one equation. You could solve that because it has only one variable, one equation. But if you have two variables like this, I will need two equations then to solve it. So I'd need another equation that has like 2y plus x equals 13 or whatever. Then I can take these and put one into the other and solve them. All right, so the point is, I want to keep it to two variables. So I'm going to use tangent of 30 would, that's the big blue triangle, would equal y over 200 plus x. Raise your hand if you guys knew that one. Okay, look at it closely again. Tangent of 30 equals y over 2 plus x, or 200 plus x. There it is. I hope that one makes sense to you. Now here's the other one. I'll use this black triangle here. Tangent of 60 has to equal opposite over adjacent y over x. There we go. Notice this equation has only two variables in it. But you're thinking, but there's a tangent in it. Tangent of 30 and tangent of 60 are easy once you have that helper triangle written down. 30, 60, 90, 1, 2, square root of 3. What is tangent of 30? It is 1 over root 3 because it's opposite over adjacent. So this turns into 1 over root 3. What is tangent of 60? Oh, down to 12 minutes left. We'll wrap up soon here. Oh, that's right. Okay, my bad. I'm going to cross off tangent of 60. Tangent of 60 is the same as TOA, opposite over adjacent, root 3 over 1. All right. So then I have two equations, this one, and you can stick the one into the other and solve. Now, sit down. We're not leaving yet, but soon. All right, let me explain. For tonight's homework, sit down. You're going to be doing all of the problems except for the very last one. Okay, and just to clarify, I mean you're going to do all of the problems except for not this one. I never assign the challenge ones. Those are always optional. So if you want to think of it as me telling you to skip two, then it's that one and that one can be skipped. All the other problems are assigned. All right, you can slide your desks back. I'd appreciate it. Have a great day. Large fries.